Hello everybody, I hope you guys are doing well. Now we are going to discuss a problem about parallel plate capacitors and dielectric. In this problem we have a capacitor, and this capacitor was charged up after connecting it to a 9-volt battery. The capacitor value is 3 microfarad. After it was charged up, we introduced and inserted an dielectric slab between the parallel plate capacitor plates, and thus because of that an extra charge, I'm going to call this charge delta Q, flew into the capacitor, and delta Q is equal to 6 times 10 to minus 5 coulomb. So that's at 6 times 10 to minus 5 coulomb charge flew into the capacitor. Okay, now the question is, what is the dielectric constant of this slab? We don't know. We need to find that. All right, so what do we know? We know the original capacitance, so that's C0 is equal to 3 microfarad. We also know the voltage V is equal to 9 volt. And we know delta Q, how much charge flew into the capacitor after inserting the dielectric slab. We need to find what? Kappa of the slab. Okay, I think our best approach to that, since we're given C and V, is to find what charge on this one, then find the charge on this one, then from finding the charge on this one we can find the capacitance of this one. Okay, why we need the capacitance on this one? Because kappa is given to the is equal to C over C0, and we know that this is always equal or bigger than 1. Okay, so let's find, we have C0, 3 microfarad, but let's find C, and the way to do that, we need to find Q using this equation, Q equals CV, to find what actually charge on this one, the original one. Since this is original, I'm going to call it Q0, I'm going to call this C0. So this whole thing is C0 and this is C. All right? And if we plug in the C0 is equal to 3 microfarad, which is 3 times 10 to minus 6 farad, and we multiply it by the voltage 9. 3 times 9 is equal to 2.7 times 10 to minus 5 coulomb. Okay, now we need to find the amount of charge on this guy. Okay, well, how much charge do we have on this guy? Let's call it Q. Okay, Q on this C, Q on C is equal to the charge on this capacitor, which is Q0, plus the charge that has flown into the capacitor because of introducing the slab. So that will be plus delta Q. All right, so Q is equal to Q0 plus delta Q. Q0, we found it, is equal to 2.7 times 10 to minus 5 plus delta Q, which is 6 times 10 to minus 5, and that gives us 8.7 times 10 to minus 5 coulomb. Notice that the charge flew into the capacitor after introducing the slab is bigger than the original charge on the capacitor itself. So 6 is bigger than 2.7 times 10 to minus 5, as you can see. All right. Now we can find C, which is the capacitance of this capacitor, and it is equal to, using this equation too, C is equal to Q over V. So Q divided by V, we know now Q is equal to 8.7 times 10 to minus 5 divided by the voltage 9 volts, still the same, of course. And now if we do this calculation, we are going to get 9.7 times 10 to minus 6 farad, or you can call it 9.7 microfarad. 9.7 microfarad. Okay. Now remember, kappa here is equal to C over C0. So C is equal to 9.7 microfarad divided by C0, which is 3 microfarad. 3 microfarad. Now this with this goes away. 9.7 divided by 3 gives us kappa is equal to 3.22. And as you can see, it's unitless because dielectric constant is unitless. All right, thank you very much.
Was a good idea.